Assalamualaikum and very good day, ladies and gentlemen. A warm welcome to all of you. My name is Afiq Hatta, representing Group 4, and today we are delighted to share with you the outcomes for our energy audit conducted for the PBL project at Tayopack Sdn Bhd, specifically focusing on the industrial building category. First and foremost, we have Mr. Razi, our lead auditor, who will be presenting on the critical aspect of load apportioning. Ms. Husnina, our dedicated auditor, will be providing insights into the room data survey with a specific focus on LUTs measurement. Ms. Shahira, another valuable member of our team, will be shedding light on the Building Energy Index, BEI, which serves as a crucial metric in our evaluation. Mr. Bukhari will be presenting the executive summary, offering a concise overview of our findings and recommendation. Ms. Azrin's presentation will delve into the room data survey, focusing on the temperature and humidity measurements, highlighting their impact on energy consumption. Mr. Irshad will be conducting a comprehensive analysis comparing average and estimated power consumption, a key aspect of our audit. Ms. Anisha Zwani, an integral member of our team, will be sharing valuable insights into power consumption data, providing a deeper understanding of the energy utilization. Last but not least, I, Mr. Afiq, will be presenting on the electrical profiling, examining the electrical systems and their efficiency. Now that you are familiar with our team and their respective roles, let us proceed to our main content. We have organized our findings systematically, and without further delay, I would like to hand over the screen to our first presenter. Thank you for your attention.
Assalamualaikum, my name is Muhammad Bukhari. For my part, we'll explain about the executive summary. For this Tayopack, the type of building is manufacturing. The number of workers is 57%. The manufacturing size is 257,953.88 square feet. The location at Jasin, Melaka. And the address is Lot 3555, Jalan Air Merbau, Kawasan Perindustrian Jasin, Batu 16 77000, Jasin, Melaka.
Assalamualaikum, my name is Afiq Hatta and I will explain about the electrical profiling for this energy audit. The annual energy consumption is summarized in table 3.1. Data is gathered from the TNB electricity bill for the past 17 months from January 2022 until May 2023. Tayopack Sdn Bhd installed a PV solar system in middle of January 2023. The green area in the table represent energy consumption after the PV solar system installation, and the highest electricity consumption was in October 2022, while the lowest was in February 2023. The PV solar system resulted in a significant reduction of electricity consumption, nearly about 40 to 50% compared to the previous year. The highest electricity bill was in April 2022, and the lowest was in February 2023. With the PV solar system, Tayopack Sdn Bhd managed to reduce electricity costs by nearly 50% compared to the previous year. Figure 1 and Figure 2 depict the annual electricity costs for 2022 and 2023 respectively. The trend line clearly shows a reduction from December 2022 to May 2023 as shown in the column chart. The introduction of the PV solar system resulted in significant cost saving. Figure 3 and Figure 4 illustrate the annual electricity consumption for 2022 and 2023 respectively. Similar to the cost trend, there is a noticeable reduction from December 2022 until May 2023 as shown in the column chart. Figure 5 and Figure 6 provide graphical representation of both annual electricity costs and consumption for 2022 and 2023. Table 2 demonstrates the total savings achieved after installing the PV solar system. It also showcases the total energy consumption charged by TNB and the total energy consumption produced by the solar system. Figure 7 displays the TNB bill for May 2023. Tayopack Sdn Bhd falls under the low voltage industrial tariff, which is tariff D, and no power factor penalties were charged as the power factor remained above 0.85 since January 2022.
Assalamualaikum, my name is Anisha Zwani binti Adnan. So today I'm going to present about power consumption data. Tayopack has 20 areas such as production area, production office, office cubicle, MD room, kitchen, pantry room, storeroom and so on. So we can see that the production area has a higher usage per month. It is because production area has appliances such as machine and high usage every day. So the lowest is storeroom. It is because no maximum usage per day, and we can see that the total power consumption data is 59,438.9497 kWh per month.
Assalamualaikum warahmatullahi wabarakatuh. My name is Ishahika bin Mazafar. Today I'm going to talk about percentage of power consumption. As Amisha Zoni said just now, the production area has the highest number of power consumption, that is 96.54%, and the lowest is storeroom 2, 0.002625%. The comparison between average and estimated power consumption. Average power consumption is 52,719.833 kWh per month, and for the estimated power consumption is 59,438.9497 kWh per month. The difference is 12.7%. Estimated power consumption is higher than the average power consumption. Because there's few factors. The first one is changes in production processes. The second one is equipment idle time. The third one is energy saving measures and optimization. The fourth one is energy management initiative, and the last one is overestimation of equipment power ratings.
So I'm going to explain for a room data survey in temperature and humidity. So we know that from the standard, it's stated that for a room temperature need to achieve a specific range, which is 22 until 27 degrees Celsius, while in humidity need to be in range 50 until 70% of RH. So as you can see from the chart, 88% of the temperature for a room in Tayopack is achieved more than 28 degrees Celsius, while a quarter half of it, 12% of room in Tayopack is achieved within the range of the standard. So due to that, it may be affected by a surrounding temperature. So it could be one of the reason for a room temperature that is more than the required standard. So for the humidity, 100% of every room in Tayopack is achieved the range in standard of MS 1525 standard.
Assalamualaikum, my name is Nur Husina. I'm going to explain for room data survey for lighting, which using luck measurement. The table shows the luck deviation with plus minus ratio of 20% for main office and production. So this is the analysis from the luck deviation data. For main office, it shows that the use of lighting is higher for overlit compared than within range and underlit, but for production unit, underlit is higher. However, the breakdown shows that the use of lighting is within range. It's generate higher because it's generate higher percentage.
For the load apportioning and energy breakdown, we have categorized all the systems by referring to power consumption data that have been collected and calculated. From all 13 systems, the printing machine consumes the most energy, which is 60.137% of all consumption at the factory. This is because the printing machine is used for the main production in the factory. This is the pie chart visualizing the energy breakdown of the Tayopack Lemberhat. As I mentioned earlier, printing machine that is represented by blue color that takes the majority area, which is 60%, and followed by other systems referred from the table. While this is the table and pie chart for the high consumption system extracted from the table earlier. The top 3 energy consumption systems are printing machine, lighting system, and cooling system.
So right now, I'll be explaining about the factor related to building energy index, which is BEI. The table shows baseline data for a year which consume power consumption with the total production. So calculating regression before building energy index helps in understanding the relationship between energy consumption and relevant factors, predicting energy needs, benchmarking performance, and ensuring compliance with energy efficiency standards. So it provides valuable insights for effective energy management, conservation efforts, and decision making in the context of building energy usage. The R squared that shows in the graph measures how well the regression model fits the observed data. So as you can see here, the R squared we achieve for this data is 0.9616, which is higher than 0.75, which indicates the variance in the dependent variable can be explained by the independent variables. So the data can be used. After done with the regression model, now we can calculate the building energy index. The building energy index that we have achieved is 615.83 kWh per year per ton.
I'm going to explain for the ESM1. We would suggest regularly cleaning aircon filter. So from power consumption data, we know that usage per day is 39.157 kilowatt hour. So for a usage per month, we get 939.768 kilowatt per hour. So we estimate a 10% energy saving. Per year, we will get 1,127.72 kilowatt hour per year. So from that, for annual energy consumption kilowatt hour per month, we will get 939.768 kilowatt hour per month. So for the annual energy cost, by calculated using tariff D, we will get 402.24 ringgit per month. So for annual energy cost per year, we will get in total of 4,826.88 ringgit per year. So from that, we have compared the estimated and annual energy consumption and cost. So the annual energy saving, we from estimated and annual, we compare, we will get in total of 845.79 kilowatt hour per month. So from that, we calculated the energy cost saving that we will get, that we will save per month is RM 41 ringgit 46 cent per month. So in total of a year, we will save the energy cost in total of 497.52 cent ringgit per year.
The second energy saving measure is to build and service fan or if required. This calculation makes if the fan speed running one third of the maximum rating, which is by using the fan regulator number 1 instead of 3. This fan consumes 134 kWh per year and will cost Rm 62.32 per year. By cleaning or changing the capacitor of the fan, it will reduce the energy consumption and save up to 109.33 kWh per year and save Rm 41.54 per year. If the capacitor is changed, 1 unit capacitor will cost Rm 6.50 and the payback period for the investment done is 2 months.
The next ESM for medium cost measures is to replacing the old bay light. At Tayopack, there are 20 units of old bay lights that still use 250 watts. The yearly usage of this old bay light is 7,800 kilowatt hour. So after ECM, we would change the wattage of high bay light into 150 watts. So the yearly usage will be decreased into 4,680 kilowatt hour. The annual energy saving that we can save will be 3,122 kilowatt hour per year, and we can save about 1,375 ringgit 92 cents. The investment cost for this project would be 2,700 ringgit, and the payback period would be 2 years.
One proposed energy saving measures ESM for medium cost is routine service maintenance on the air conditioning system. Table 3.3 shows the total power consumption of the air conditioning system before implementing the ESM, which is 39,165 kilowatt hour for daily usage and 12,219 kilowatt hour for yearly usage. Table 3.4 displays the estimated power consumption of the air conditioning system after implementing the ESM. The ESM is expected to reduce energy consumption by approximately 1/3 or 33.33% of the total energy consumption. And table 3.5 summarizes the annual energy cost savings achieved by implementing the ESM. The estimated investment cost for the ESM is approximately 1,960 ringgit and the payback period is around 1 year and 2 months. Figure 3.1 illustrates the process of performing service maintenance on air conditioning unit for both ceiling cassette and wall mounted units.
Energy saving measures for high cost is rebuild exhaust fan at every machine on production. So this is the list of appliances that have, which is IR machine, cutting machine, glue machine, slitting machine, edit machine and printing machine. So for the total usage, before we apply the ESM is 313,872 kilowatt hour per year, and after we apply the ESM is 552,484.8 kilowatt hour per year. For the annual energy cost is 256,373.28 ringgit Malaysia per year, and for the annual energy cost saving is 26,340.72 ringgit Malaysia per year, and for the total investment cost is 15,000 ringgit Malaysia, and the payback period is 6 months.
An energy audit begins with a comprehensive analysis of the building's energy consumption. During the audit, we evaluate the efficiency of critical systems like HVAC, lighting, controls. We compare audited equipment with energy efficient alternatives to uncover potential energy saving opportunities. The conclusion of the energy audit provides valuable insight into how energy is being used within the building. It highlights major energy consuming areas and offers targeted recommendations for improvements. So the table inside the slide shows recommendation that may include retrofitting or upgrading the equipment. So we can also adopt energy efficient technologies, optimize control system, and modifying operational practice. In conclusion, an energy audit offers valuable insights, cost saving opportunities, and environmental benefits. It is a crucial step towards optimizing energy performance, reducing costs, and promoting sustainability.